Okay, today we are going to look at logarithm in more details. This time we are going to talk about the laws that we can apply to logarithmic operations. So have your formula sheet out because they are all on your formula sheet. They're here. Laws of logarithms. Alright, so the first one is the product law. If you have the log base of b with m times n, then you can split this up into log base b m plus log base b n. So multiply plus, just like the exponent law stuff. Let's work on an example. So let's say if we have log base 6 of 20, we can write that as, well, you might be wondering, why do we want to do this? Can we just do it on a graphing calculator? Yes, but then the thing is, they may ask you to find the exact value or something. You may not always get an exact value. Okay, so in this case, you can apply this by, well, first of all, it doesn't look anything like this, so you might want to split this up. So into like 1 times 20, 2 times 10, 4 times 3. So in this case, let's split this up into 4 times 5. So we can write that as log base 6 of 5 times 4. Because 5 times 4 gives you 20. The same, right? Then we can apply the product law, which split up this. So we can write it as log base 6 of 5 plus log base 6 of 4. So you can do this on your graphing calculator. So log base 6, 20, whatever that is, then do this log base 6, 5 plus log base 6, 4. You end up with the same answer. Alright, so next, quotient law. So log base b of m divided by n, you can split that up into log base b of m minus log base b of n. As I said, it's kind of like the exponent law stuff. Anyway, so divide minus. Now let's do this. Let's do the same one here. Log base 6, 20. If we want to apply the quotient law, then you can write that as 20 divided by 1, 40 divided by 2, and so many different possibilities. So let's stick with 40 divided by 2. So we can write log base 620 as log base 6 of 40 divided by 2. Then we can apply the quotient law. So we do minus then. So we have log base 6 of 40 minus log base 6 of 2. And again, you can do these two separately. Plug this into your calculator, log base 620, enter, you get one number, and then do this log base 640 minus log base 62. Whatever number you get is the same, will be the same as this one here. Last one, well, not the last one, the last new one that we have not talked about, which is the power law. So which is this. So log base b m raised to the power of n, you can take the exponent out and then put that in front. And that applies to more complicated exponents. So if you have log base b m raised to the power of n, and then you take the p root, then you can rewrite this exponent you write that on the top. So if you rewrite this one here, you can write that as m raised to the power of n over p. Okay, so based on the power law, you can move the exponent outside of the log, so like this. So n over p. So let's do 2 examples here to illustrate how it works briefly. So if you look at this one here, we can say log base 5, 8 to the power of 3. You can rewrite that as move this, the exponent, to the front or outside of the log. So that becomes 3 log base 5 of 8. So you can plug this into your calculator, you get one value, and then do this, you will get the same value. Okay, so for this one here, so let's do log base 3 7 raised to the power of 5 and queen root. Then you can rewrite this as log base 3 and then 7 raised to the power of 5 over 4. Then just like that, you can move this exponent outside of the logarithm. There is actually, like, this whole thing is under the influence of log, so you can rewrite that as 5 over 4 log base 3 of 7. Okay, and then last one here, we actually talk about that change of base law. So if you look at this, let me check off all this. Check. Check, check, check. So the one I'm going to talk about right now, actually we have talked about this one already. So if you look at this one here, log base b of c is the same as log c divided by log b. And in this case, as long as you have the same common base, it will be the same. But to make life easy, we usually talk about log base 10, the common log. Okay. Alright, still do one example here. So let's say log base 6 32. For those of you who don't have, who are not using the newer model of the TI calculator, as we talked about on the last day, this is what you can do. So you can take advantage of the change of base law. So log of 32 divided by log of 6. What's the base here? Well, to make life easy, let's just use base 10, and then we can solve for whatever we have. Alright, so if you know you need to apply the laws of logarithm, here you go. So as I mentioned in the first half of this unit, the laws of exponents, they are not here because those are the prior knowledge you should have learned. You should have still remember from last year. Okay, so let's work out some examples. So first one here, expand the following expressions. So you can rewrite this. This one should be easy. So multiply, so that means you add. So split up the logarithm. Log base 7 of x plus log base 7 of y. Okay, next one. So there are 2 ways you can finish this. Doesn't matter which way. I'll show you both ways, at least for this one here. So if you look at this, you can write this as, because you have divide, so therefore you can do, but you can split up the log and then do minus. So log base 4 of 1 minus log base 4 of x cubed. And as you know, if you take the log of 1, that always gives you 0. and then for this one here, you can apply the power law. So move the 3 up front. So minus 3 log base 4, and then 0 minus that, so that gives you a negative term. So the final answer is negative 3 log base 4x. That's one way. Some of you may see this question in a different way, so let's put it here. So another way is, if you look at this, some of you may say, oh, log base 4. Some of you may say 1 over x raised to the power of 3. Isn't this the same as x raised to the power of 3? Absolutely. Then what can you do? Well, apply the power law, move the exponent to the front. So that means you would have negative 3 log base 4 of x. So look at this, same answer. So it doesn't matter which one you do. Alright, next one. Okay, so this one here, you might want to pause for a few seconds, think about this, give it a shot. Alright, so this one, you can do it this way. So let's look at this as one entity. So you have this divided by that. Don't try to make it too complicated, saying that, oh, the A times B divided by C times D. Don't do that. Okay, so let's look at this and that as one entity. So if you look at this, we have divide. So we can write that as log base 5 of AB minus log base 5 of CD. Now you can look at each one separately. So just within this one here, you have A times B, so you can split that up, except this time you'll be adding. Same thing here, you have multiply, so therefore when you split this up, you have adding. So log base 5 of A plus log base 5 of B, and then minus here, do the same thing, log base 5 of C plus log base 5 of D. Congratulations, you just screwed up. What did you screw up? If you look at this here, as I mentioned in class in math, every time you deal with negative sign or minus, that's nasty. Fraction is also nasty. So you should have put brackets around. This negative applies to this whole thing, so you should have put the brackets around. What does that do? It will change the sign to negative. So anyway, let's quickly do this. Log base 5a plus log base 5b, and then negative positive gives you negative, minus log base 5c, negative positive gives you negative. This is the big deal, okay? Minus log base 5d. Okay, so let's quickly do the last one. Again, I hope you pause already and try it out yourself, but anyway, so this one we can do it in 2 different ways. Let's do first way first. I'll just do it one way. If you figure the other way, you go ahead. So this one, log base 7 square root of x and y, so that means you can take out the square root and then replace it with the exponent of -1. So log base 7 of xy, better put the brackets around because the square root, which is the exponent now of 1/2, applies to both, and then you just put the exponent 1/2 up front. So that gives you negative log of base 7 of xy, and then after that you can split this up because you have multiplying, so therefore you can split this up as plus. So that means you have this log base 7 of x plus log base 7 y, and you screw up because this 1/2 applies to everything. So do this. On the second thought, I will show you the second way. So this. Now if you want, you can apply the square root to x and y separately. So you have log base of 7 just like what we had for the first method. Okay, and then you can apply the exponent 1/2 to x and y separately. So log base 7 x 1/2 and y raised to the power of 1/2. Then you can apply the product law. So split this up and add them. So log base 7 x 1/2 plus log base 7 y 1/2. Then apply the power law. Sorry, not the power law. Try separately. Move the 1/2 up front. Move the 1/2 up front. Then you would have 1/2 log base 7 x plus 1/2 log base 7 y. So if you, I know this doesn't quite look like that, but if you apply the 1/2 here, or apply 1/2 here, 1/2 here, you get that. Or if you factor the common factor 1/2, you get the same thing. So now we can use the log laws to evaluate. So again, you can do it the easy way by plugging all this into your calculator, and that's not math, so I'm not going to just leave you like that. Instead, I'm going to show you algebraically. So you can use your calculator to check our final answer. Anyway, so if you don't want to listen to this part and simply plug all this into your graphing calculator, you go ahead. So let's do this here. Obviously, things are getting more complicated. So if you look at that, they all have the same base. So therefore, we can apply the log laws, right? So plus means multiplying, minus means dividing. So let's put down the common base, log base 6, and then inside that you have plus, so 8 times 9. 8 times 9 minus means divide, divided by 2. And then of course you can simplify what's inside the brackets. So log base 6 and 8 times 9 divided by 2, that gives you 36. And I hope you can have your spidey sense and see that, well, 6 and 36, they are related. So we can write it as log base 6 of, instead of writing 36, I can write that as 6 squared. Then you either move the 2 up front and then cancel this whole thing out, or just cancel this whole thing out and then you end up with a 2. Remember, if the base of your log is the same as the base of your exponent, that whole thing cancel out. So that means in this case the answer is 2. Alright, so question B, there are 2 ways you can do this. I'll just show you one way. If that way doesn't make sense, look at my PDF notes and then have a look at the second way, because I don't want to do every question in 2 ways. That would take us twice the time to get through the notes. Alright, so if you look at this one here, so equals, so this is log base 3, 9 times root 3. So times, that means we can split up the log and then add them up. So log base 3 of 9 plus log base 3 of root 3, and then continue log base 3 of 9. Well, for 9 you can write that as 3 squared. I hope you can see that. And then for the square root here, let's convert that into an exponent of 1/2. So log base 3 of 3 raised to the power of 1/2. Now this would cancel out, so that gives you just 2. And then for this one, same thing, cancel out. So that gives you 1/2. So if you want, you can write your answer as 2 and 1/2, or if you want to write that as improper fraction, that gives you 5/2. Alright, so let's keep it going.